Great. Now it's officially started. Um, you all have received the link, right? Um, Let me post that one more time here. It's in your emails or your parents' email. And where's the chat window? Here's the chat window. Let me put that link there. Yeah, that's the link. If you have any questions, you always can ask in the chat window. What else I forgot? I think that's it. All right. Let's start. Um, so I think I see many of you took either the PHP or HTML or Java in the past. I'm really glad that you are coming back for this uh, course. This is the first time I teach a database course. I think some of you asked about this in the past. I hesitated. I thought, oh, database maybe is too difficult for you. But after a few courses like Java, PHP, HTML, I feel you guys really great at learning and quick learners can understand the complex things. So now I feel very confident that you will learn something or learn a lot, um, not just the programming languages and maybe the database. Okay, we all have heard a lot about lately, machine learning, uh, you know, data science or data modeling or, artificial intelligence, AI, facial recognition, all those fancy, computer-related concepts or words. That seems to be scary, but after all, they are just programming, you know, computer programming, and without actually, there's one thing is missing: the database. Without database, all those fancy things can't do much. After all, all these work or computer science and advancement is rely on database. Um, a database is just data, but it not different from like, oh, okay, just data stored on the storage on the disk. That's not enough actually. Think about it. If you put that a lot of data, terabytes, gigabyte, petabyte data on disk, then you still can't do much because just to write those data is time consuming and even read them is very time consuming. So you have to put in a way that you can quickly retrieve the data and then do something, do some computation, do some analysis, um, so you can get result quickly, right? So then there's a database uh, database management system comes into play. Um, Among many, there are many, database management systems, and among them, MySQL. Um, let's see, I call it MySQL. Some people call it MySQL. I think MySQL is good enough. Yeah, MySQL is a very popular and easy to use open source relational database management system. A relational database management system ensures is RDBMS, but I can't read that. But if you see RDBMS, it stands for Relational Database Management System. Um, so here, the database management system we know, well, it's kind of a database. But relational, that's the key word here. It's like in the database, you have tables. They are relational, means the tables relate to each other. It's not just like scatting around isolated tables. If you just got a bunch of tables and they don't relate to each other, then it it doesn't do much. It's not that helpful at all. Um, but only when the tables you created are relating to each other, um, then it becomes very useful. Uh, Tables, we will talk that in a minute. So in database, you got a tables. Table basically, the table like catalog, like a table is just a list of data. We will look at that momentarily. So what is MySQL? MySQL, of course, remember that MySQL is a relational database. Um, and that forwards, you don't always use management system. It's becoming too wordy. You say, oh, relational database. So that's good enough. And it's open source. That's important. Like you probably heard of like a big database system like Oracle. That's huge, but it's not open source. You don't see their source code. If you're good at the database, say, oh, you know what? I don't like this function. I don't like the feature. I want to change it. Can I, write a new code and give that to you? And they said, no, we don't take your code. Our source code is closed, not open to anyone, to the world. So versus that closed source code, this MySQL is open source, which means someday if you become a computer scientist or computer programmer, doesn't have to be scientist, you feel so good, so you can write a database program and then you want to contribute. Sure, you can do it. You check out the source code and make a modification and then submit your new code. Of course, you just cannot submit and then accept it by the world. And someone in control voluntarily review your code and make sure it makes sense. Then you say, okay, fine, your code looks good and useful, that we take it. Then your code will be part of this open sourced MySQL system. Okay, that's called open source. Since it's open source and most of the contributors are, volunteers, they don't ask for money to contribute. They just, okay, I just want to contribute for free. So that's why when you use it, then it's free. That's why MySQL is free. That's a key feature of MySQL. Um, then you may ask, oh, open source, oh, free, must be junk. But actually, no. MySQL is ideal for both small and large applications. Um, you can use it for small projects or even like as small as a personal apps, write little application and create small database for yourself, for fun, or for your school, for your parents, for a small company. That's fine. MySQL is good. And it can be used for large applications. You may heard of YouTube. We are using YouTube now. Um, Uber, right? And many other big companies, they use MySQL. So it can be, yeah, it can be used for large applications. Involves many developers. The last feature is cross-platform. Remember Microsoft, they have a database system called SQL Server. And that SQL Server is like bigger than MySQL but smaller than Oracle. It's not open source. It's not free. Actually, it's pretty expensive. And it's not really cross-platform. Platform means the computer, right? You use Mac, I use PC, Windows, then there's a server. They're all different operating systems. They're called different platforms. Not cross-platform means, oh, SQL Server only run the Microsoft operating systems, not Linux, not Mac, no other type of platforms. So MySQL is cross-platform. You can install MySQL on Windows, Linux, Unix, you know, um, Mac. That's called a cross-platform. So all these things are showing that MySQL is flexible, easy to use. And who uses MySQL? I just mentioned that earlier. Yeah, some huge websites like Facebook, Twitter, Airbnb, Booking.com, where you buy tickets, Uber, GitHub, YouTube. YouTube is a video. GitHub is a actually software repository or software versioning system. Um, if you are a developer, well, if you in future become a computer science major, you will know GitHub. GitHub basically, if I write a lot of code, where do I store them? How do I track them? If I make a change, how do I know what change I made and where? So use GitHub. That's a big thing actually to track to store your software. Content management system like yeah, WordPress, Drupal, um, all those names don't even Joomla, Contour. They are actually the big tools, big website creating softwares. Very large number of web developers around the world. Yeah, yeah, almost all the developers they like give me a second. I got a call from my actually nurse. Give me a second, okay? I'm going to mute you or if I can. All right, I'm done with that. Let's continue. Let's see. And mostly, I'm muted. Yes. And most important, most important, I think, and most importantly, the Southern Connect Chinese School. We use MySQL. Our website, you register courses, and pay the course, pay tuitions. We use MySQL. How to use MySQL? Well, just example, yeah, how to use MySQL typically, let's say you want to build a website that show data from a database. Typically, you need a few things. First, you need a database to store your data or save your data. Save the data, yeah, the user enter the data, and of course you need to know a programming language like a PHP. In the past we learned, or getting fancier like a Java or JavaScript, some other languages too, but PHP is good enough. That's what we use. Um, Python, yes. You can ask Python. Yeah, you can use Python. Almost any programming language can be used to develop website. Okay. Um, yeah, PHP, quick, fast, and Java. Yeah, Python, Ruby, Rail, many languages. C sharp. Um, then yeah. So you got a database, you got a programming language to write the server-side code, and then you use a query. That's what we are learning. We are going to use MySQL and the SQL query, SQL language, to query the database, uh, and then you know display the query result um, to the browser using HTML and style sheet, CSS, HTML, CSS. Some of you probably have learned that. So if you know all these things, all these four things, or three things primarily, three things: SQL, PHP or HTML, then you can build a website that tied to a database as a backend. Okay. I don't want to track my time. There we go. Okay. Well, time flies fast. Next thing is table. Yeah, database table. A table is a collection of related data entries, and it consists of columns and rows. Yep. So table, you know the table columns, rows, typical, right? Table, like you draw a table on a paper. So here in the screen here, there's a table. Typically, you have the columns with a title, customer ID, name, customer name, contact name, address, city, well, yeah, street, called a street name, city, postcode, country. This is example table. That's the columns. Column means different type data, different data, and then the rows. The row ID like customer ID in a row, first row, second row, third row. Well, by the way, in a table, the customer ID doesn't have to it doesn't have to start with one. It can start, any number. Normally, as long as it's unique, you can start with 1000, 1000, or 1001, or 1002. So it's not always 1, 2, 3, 4, 5. So columns, rows is a table. Um, we can't see the relationship here yet, but we will see that in a minute. A column holds specific information about every record in the table, right? So the, let's see, customer name, it shows the different names, um, and different names for different rows. But sometimes it can repeat, but you don't want they repeat all the time. Let's see if got a customer name, and then for each row is the same customer, and then that's something wrong, and you probably want to separate that column out, so you don't want to repeat the data. Remember, store data in computer on computer disk is, well, nowadays it's not that expensive, but think about if you store too much data or redundant data on the disk, then you are wasting storage and then slowing your access or slowing down your performance, application performance. Um, so that's why when you design the table, you don't want to store the same data unnecessarily repeatedly, okay? A record or a row, so if you say a table record or table row, that also means the same thing. A row is a row. Is each individual entry that exists in a table. Is each individual entry that exists in a table. Yes. Right. Yeah, a record, a row, or an entry. Three things means one thing, it's just a row. Um, so that's a table. So in summary, this table has 7 columns and 5 rows, or 5 records, or 5 entries. So that's a table. Now let's look at the relations of the database. Why we call it a relational database? So we have a table, right? Now the relations means a relational database defines database relationships in the form of tables. It means you have multiple tables, and those tables relate to each other. Then that become a relational database. So you can put this in backforth in different way to express. Relational database means relational. You have relational tables. You can have one table. You got a database and then got a single table. Actually, that's legal, and actually that's pretty common. Some people they just design one huge table in a database, just one table. In that way, you kind of don't see the relations, right? But it's still okay. If you have a very small app, You don't need more than one table. Fine, you can have one table, but you don't have a table that has many columns. If you have many columns, then maybe it's a good idea to split that single table to more than one. Ethan asked a question. I once had to use a database for a coding project, but I didn't know what to use because everything's so complicated. Oh, yeah, so complicated. Yes, that involves database design. If you split a table, how to relate the data? Yes. When you split one table into two or three, you need to define a column that both table refer to. Uh, we will see that. We will see that. Okay. So you have a common column as a called in one table called a primary key, in another table called a foreign key. They refer to each other and tie the two tables together. Okay. But isn't that creating more data than necessary? Yes. For relationship, yes, that's a necessary more data because you do need that extra column to relate them. Okay, let's see. Let's come back to our slide and we will see that concept. So again, tables related are related to each other based on data common to each. See, that's exactly what we just talked. You need a common column, a common data, either common data, a common column between two tables in order to relate them. Okay, otherwise, how can you relate them? Let's see. Let's start with one example. Example one here. Example one. Um, three example tables: customers, orders, and shippers from Northwind database. Northwind it's a when you learn database, there's a set of tables. There's a example database called a Northwind. Um, Whatever the computer science or database teacher or professor, um, they came up many years ago. Almost all the developers knows Northwind database. It's basically a virtual or just for teaching purpose. No one really use it for real work. It's just for teaching purpose. We call it a Northwind database. Northwind probably is a um, non-existent company called Northwind, and they got a database. They got products, the customers, and so on. They got orders and shippers, so those things. But basically, it's just for teaching. It's a example database. But anyway, so this database is a relational database. It has many tables, but at least some of them are the common ones or popular ones. One table is called customers. Let's see this company, Northwind company, similar to Walmart, got customers. So the company wants to track all the customers uh, it has. So in the customer table, let's see, think about the customers. Say, oh, customer number one or customer ID 12345. You assign a customer a unique ID, just like a phone number, a social security number. Similar, like customer ID has to be unique. So you don't want to have two customers to have the same ID, right? So customer ID, column one, and then customer name, probably the full name. Um, in reality, I think, or in our school website, you want to separate the name. This is the full name, obviously, first name and last name. You want to separate, you know, two columns. Customer name last, or customer last name, customer first name, and even customer middle name. Because if you don't do that, oh well, the front end control that because you probably have used this online order. You always when you fill out a web form, it always ask what's your first name, what's your last name, what's your middle name or middle initial, something like that. Okay. But anyway, so we just got an idea. This column is name, but in practical design, probably you want to separate that into first, middle, and last. And contact name similarly, contact last name. Um, yeah, right. They want to separate that because I guess if the customer is a teenager or a young person, then you want to have a adult contact name. Um, so that's why they list two names. And of course, address, the street name and street name number, and maybe apartment number, including the apartment number and the city passcode. Well, this is like a foreign countries. In America, you probably want have a stay name. So this looks like a by European professor designed this table. Anyway, so this is their customer table. You can see that different columns, different the properties or data about the customer. This is a person table, and then you have a customer want to order something. Then you want to track the orders. So in the order table, you want have a order ID, order, so you can have different entries. As long as your order ID is unique, then you can have a unique entry, right? A row here. Um, so in the order, you probably want to say, well, the order, the product name, quantity, and the order day, right? That's normally you would put it into an order table, right? What the customer ordered, or what the quantity, price, cost, and then instead of seeing those information, we see some columns here right away. Customer ID, yeah, that's good. If you then if there's if customer 5, customer ID 5, oh, okay, that refer back to the customer table is Burglons, what a snap. Oh, that's not English. Give up. So it's Sweden. Okay, Sweden. So customer from Sweden ordered something. Now you can see that this customer ID match that customer ID. Then that's called a common data. So number 5 there, number 5 here. And this is a relationship. So this customer ID here and customer ID here, that's a relationship. This is extra data, but it's necessary because we want to relate the order table with the customer table. Okay. Kevin got a question, small question, because I don't think I understand completely. Does MySQL sort a database? Yes, or database, they can sort a database.
Okay, thank you.
Yeah, normally they sort by the ID here. See the ID, that's the default. Um, yes, it's sorted, but when you query it, you can change the sorting. When you run the query, we will learn that later. When you write a query and you query the table, you can change the order. You can, there's I think order by is called the sort, but in query called order by, we learn that later. You can change the order, okay? And you can change the order there. But okay, um, so this is a relation, right? And you see employee ID. Where's that from? Well, there should be another table. We only see customers order shippers. In this database, there should be another table called employee, the employees table. And the employees, there's a column called employee ID, and then the name and the phone number, address, blah blah. When hired, this company's employee. Why that is in the order table? It is necessary because who processed this order? Yeah, the customer wanted to buy something, order something online, then the customer entered those, yeah, order a product, and you want to save that order, and then you want to know who processed the order, which employee fulfill the order, process the order. So you want put that into the order table, um, right? So then the employee ID is from the employees table, but that table is not listed here. And also, oh, there's a pink here, the column called shipper ID. Um, so yeah, who shipped the product? By the post office, USPS, or UPS, or nowadays maybe just like Amazon. If you order something from Amazon, maybe the Amazon itself, um, or FedEx. Who knows? So there's another table called the shippers, and in that table, the first column must be, shipper ID. So now you can see the relations. I, I in the order table, you want to know which customer ordered this thing, and you want to know which employee processed this order, and you want to know who shipped the product to the customer. So just between these two tables, if we only want to see the match the green boxes. So that's a summary here. The relationship between the customers and the orders is a customer ID column. So that column is the data, common data, or the data coming to those tables, that establishes the relationship between those two tables. And then similarly, between the orders and the shippers table, oh yeah, the shippers, Speedy Express, okay, United Package, Federal Shipping. This must be European shippers. But anyway, so between the orders and the shippers, we use the shipper ID to link those two tables, or to relate these two tables. So the relationship between orders and the shippers is a shipper ID column. Okay, so we will spend a lot of time on this, the common columns, because that's the core of relational database. Um, so let's look at another example more closer to us. Example 2, we only list two tables. Um, Classes, or courses. We have different courses. This is from us, dancing class, chess, art. The one here is called a grade or subject. The 1, 2, 3, that's the language lesson, the Chinese, for grade 1, 2, 3, 4, 5, all the way to 10. So that's a grade 1, 2, 3, 4. All subject, or for the non for the enrichment classes, we call a subject called dancing or art, draw, math, you know, Java. Um, so that's the class name or course title, and which year, which term. Okay, and there's a class ID that's unique. And in the orange box, teacher member ID, or actually, all we call it a member ID, or we call it a teacher member ID. Um, we have different kind of members, regular member, and the teacher also in our member table called a teacher member ID. And it shows which teacher teach this class. Think about it. If we don't have a teacher table, then this class table we'll have to include the teacher information. That require many columns. Teacher name, teacher phone number, teacher email, teacher address, and many columns you have to add to this class table. That make this class table huge, right? That's why we want to separate the teacher out from the class table, only leave a column called a teacher ID. So the ID just point to which teacher in the teacher table. So this is the class table. And then we have this member table or teachers table. Actually, in our case, actually just the member table. But we can just call it a teacher table. In the teacher table, the first column is the ID. We call it a member ID, all right? Or teacher member ID, just member ID, just ID. And then they list last name, first name, email, add email, phone number, home address, um, and so on. So this table has many more columns. I don't show them here, just show last name, first name, and ID. And now, then, since that column and that column that both refer to the teacher ID, then those two tables are related. Now, so we know, okay, the class table and teacher table, we know which teacher teach which class. You may ask, oh, that column is called a teacher member ID and that column is called a member ID. Are they different? Yeah, the title different, but the store data is the same. The definition for the relation is that you need to have data common to both tables. It doesn't say you have to, the data title has to be the same. It's just the data itself the same. As long as the data itself, the data, self are same, that's fine. This is only the column name, column title. Normally you call them same thing, but sometime member ID here, but in this table maybe there's another member ID. So you want to maybe the class here has some other member ID, not a member ID. So you can to make it to to clarify. You can rename it a little bit. Um, so only when you run the query join these two tables, you want as long as you know which column join to which use which column as the relation, you're fine. So yeah, it's okay to have different column name. Uh, okay, so that's a relationship that relate the two tables together. And again, this is our school's database of tables. Okay. All right. Any questions? No, that's good. That's good. Um, I forgot to show. Oh yeah, all these things, you can if you need additional reading reference material, you can um, remember this. We have been using this website for many terms. w3schools.com. Okay, if you come to the old home and then click tutorials, you can just say learn MySQL. Okay, so learn MySQL and is this. So what we have been talking about mostly, refer here, definition, what is that? What's a database table? What is a relational database table? They all from here. And shapers, I added our schools. All right. And so you can see that next lesson we learn the tables database. We will start to um, learn the SQL language. um, you know, for example, oh, I want to select all the records from the custom table. You can just select from the table, then you get a result. We will learn that, okay? And many, many more. Don't be scared. We will learn little by little. And all right. Uh, so that's it. And let's see. Where is it? Here. Yeah, we have a few questions. You probably already know the answer. Think about it. That's all. That's all for today. And I'll see you all next Friday. If you have questions, you can stop. Okay? You can wait, and I can try to answer. All right. Bye bye, everyone.
Bye.
Yeah. Bye.
Bye.
Do we have homework?
I just show on the screen only 3 questions. If you follow the link at the end, there's a homework. Only 3 simple questions. Okay.
Okay, thank you.
All right. Bye
Bye.
bye. Yeah.